Have you ever wondered how your computer's operating system works? How it manages to juggle a multitude of tasks, keeping everything running smoothly? Well, prepare to dive into the fascinating world of operating systems and their intricate components. An operating system, or OS, acts as an intermediary between the user and the computer hardware. It's like a translator that speaks both human and machine languages, bridging the gap and making sure everything runs smoothly. There are three main components to an operating system: the kernel, the I/O subsystem, and the microkernel. The kernel, the heart of an operating system, is the core program that controls all other programs in a computer. It manages the system's resources and communicates directly with the hardware. You can think of the kernel as the conductor of an orchestra, directing the various instruments, or in this case, hardware components, to create a harmonious performance. Next, there's the I/O subsystem. This component manages all input and output operations. Whether you're typing on your keyboard, clicking your mouse, or watching a video, the I/O subsystem is hard at work, ensuring all these tasks are carried out efficiently. The microkernel, on the other hand, is a minimalistic approach to kernel design. It only includes the bare minimum necessary for the system to function, such as basic inter-process communication and basic scheduling. All other functionalities, like device drivers or file systems, run in separate processes outside of the kernel. Now let's delve a bit deeper and compare two types of kernels: monolithic kernels and microkernels. Monolithic kernels are essentially one large program with complete control over the system. They include device drivers, memory management, file systems, and more, all within the kernel. This design provides high performance and efficiency, as all services are tightly integrated. However, it's also more prone to errors and crashes, since a bug in one part of the kernel can bring down the entire system. Microkernels, in contrast, aim for simplicity and reliability. They keep only the most essential services within the kernel, such as inter-process communication and basic scheduling. All other services run as separate processes, isolated from the kernel. This design makes the system more resilient to bugs and crashes, as a failure in one service doesn't affect the rest of the system. However, it also results in a performance overhead, as more context switches and communication are required between the kernel and the services. In summary, the operating system is a complex and essential part of your computer that ensures smooth operation of all tasks. Its main components, the kernel, the I/O subsystem, and the microkernel, work together to manage resources and facilitate communication between the user and the hardware. The choice between monolithic kernels and microkernels depends on the trade-off between performance and reliability. So, the next time you use your computer, remember the intricate dance of processes and components happening behind the scenes, all orchestrated by the operating system. Isn't it fascinating to comprehend the harmony in the chaos?